All right, thank you. And looking forward to the presentation today and looking forward to hearing your feedback. As Elaine said, I'm John Stratton. I'm the product line manager for software at FreeWave. So that is all of our software that runs on our Zoom Link series hardware as well as our new Fusion series hardware. So who is FreeWave? If you are familiar with FreeWave from the past, you know us for our long range and reliable radio and connectivity options, but we are significantly expanding and software is part of that. And so we now provide an edge compute platform with gateways, edge data, analytics, and applications. So this FreeWave Edge is one of our big launches this year that is part of that. In terms of industries that we serve, government and defense, precision ag, oil and gas, anywhere there's a need for remote, rugged, reliable connectivity and data collection. And some of our highlighted clients here, you'll see both some big names and small operations here as well. We can definitely support a wide range of customers in a wide range of industries. So looking forward to getting your feedback and hopefully working with you on a couple opportunities. So the FreeWave Edge software that we're talking about today is available on the Zoom family of hardware. So this is a edge compute hardware board with a Z9 Zoom Link radio module on it. The Zoom Edge also includes expandable I/O module support that's available via Modbus or REST API, and we provide industrial grade temperature ratings here, up to 75 degrees C for enclosed modules and 85 degrees C for board level. And we are C1D2 certified for hazardous environments. So really rugged remote hardware here. And let's look at the overall FreeWave ecosystem. So if we look at a potential FreeWave radio network here of a Zoom Edge on a pipeline or a water tank, a Zoom Link on pivot irrigation, or our new Fusion bridge that adds Wi-Fi capability, all of that can run the FreeWave Edge data platform that is going to be the core of our presentation today. So FreeWave Edge provides edge data processing. It provides protocol and I/O inputs. So today we support Modbus, Emerson Rock, and the FreeWave I/O on the Zoom Edge. In terms of our data platform, we have the on-edge storage and the store and forward feature. So even if you lose connectivity, you still get your data collected and get your data sent once that connection is reestablished. And then we provide publishing mainly via MQTT, but also via email to your own enterprise or SCADA system or your cloud IoT platform. So wherever you need the data to go from a managing your business and your operation perspective, we can get it there through FreeWave Edge. And the advantage of FreeWave Edge, if you've previously used Edge hardware but had to get software from another source, we now provide the hardware, the software, and the connectivity all from a single source, all in a single box. So let's jump into a couple of the problems we think we solve here. So we've got two big problems that we think we solve with FreeWave Edge. And in this diagram, we're showing on the left an RTU and a PLC out in the field and a traditional SCADA system doing centralized polling over the air on the right. And so we're asking from the SCADA system, what's the pressure? It's the same as last time. But an hour later, let's say you lose your connection and the SCADA system asks, what's the pressure? If there's no connection, there's no response, so you're losing data for that particular sample point. Half an hour later, there's no pole, but say there's a pressure spike or an abnormal event on the PLC. So if that pressure spike happens outside of a polling rate, you also lose that data and don't know that happens from the SCADA system. And then half an hour later, you get another poll that looks the same as last time. You don't know what happened in your operation. So with FreeWave Edge, what we do is we install FreeWave ZoomLink hardware, ZoomEdge hardware next to that PLC, and we do high-speed edge polling with store and forward. So we can poll up to once per second and use the store and forward feature. So if that radio link is lost, we're still storing the data on the device. As soon as that radio link is reestablished, we are sending that data over the air. So you get the data as soon as your connection is reestablished. And the other thing we do with our high-speed edge polling is we can now do alerts. So if we find out what's the pressure's up, okay, we can send that pressure alert immediately without waiting for store and forward, without waiting for a SCADA poll. So you immediately know what's happening on your operation. The other challenge we think FreeWave Edge provides a good solution for is bandwidth. And if you've operated radio networks in the field, you know that bandwidth is a limited and highly valuable resource, and poll response takes up a lot of that bandwidth. So in this case, we've got our SCADA system on the left, the PLC out in the field on the right, and cycling through using poll response is using up a lot of bandwidth on those sites. So with FreeWave Edge, we are now doing the polling locally hardwired between the FreeWave device and the PLC. And instead of doing inefficient two-way communication over the air, we're now doing much more efficient one-way communication over the air. And we're also doing those alerts that if something goes wrong, we immediately send the message rather than having to wait. So this is both getting you higher resolution data and it's getting you more efficiency with your limited network resources. With our store and forward feature, which is one of the things we're going to show in our demonstration here shortly, we are storing data on that FreeWave device on the storage in the hardware. So if you lose connection, we're still doing the edge polling, still doing the edge storage. And as soon as the connection is reestablished, we're resending all that data. So if we take an example here of 25 tags on an individual site, retrieving data every 30 seconds, conservatively speaking, we can store up to 22 days worth of data. Over 3 weeks of data is what's potentially covered by store and forward on FreeWave Edge. Of course, that's affected by network conditions and power conditions and all that good stuff, but this is meant to give you an idea of the capability of the hardware, the capability of the software, and provide how often you can store data. And you see here, depending on how many tags you have or what your polling rate is, we can store weeks or months or over a year of data in that software database. So we think that provides a good solution to the lost connection problem for sure. With that, we're going to do a quick demonstration. So this is a live demo of FreeWave Edge running on ZoomLink hardware. So this is one of our demonstration boards. And if you're familiar with FreeWave products and the ZoomLink web UI, you'll be familiar with this screen. If you have not used FreeWave before, all of our Zoom and Fusion products are configured via this on-device website. So you go to the device IP address and you get an easy-to-use website to configure the radio settings, to configure the network settings, to connect to the rest of your network, and configure and get information about the device. With FreeWave Edge, we add a tab here at the top for FreeWave Edge. If you're on the Zoom Edge hardware with the I/O, there's also an I/O tab here at the top to configure your 4 to 20 milliamp sensors and your other I/O hardware. So we're going to jump into FreeWave Edge. And the way this is set up is this is a top to bottom wizard style user interface. So start at the top, work your way down, and you've got a fully operational system by the end. So we're using Modbus for our example, but whether it's I/O on the Zoom Edge, whether it's Rock or FlowBoss, or whether you are sending in your own data via our third-party API, it's all treated pretty similarly. And as soon as it shows up here, it's all treated the same for store and forward and alerting. So with Modbus, we start with an import of registers from a CSV file, easy to do in Excel. And then we can edit these Modbus values. So just wanted to show a quick view of how this works. We've got our Modbus values on the left. We've got our custom units on the right. So if your PLC reports in 4 to 20 milliamps for I/O or reports in percentages, you can do your custom units in FreeWave Edge and put in any text string you want here. Degrees Fahrenheit, degrees Celsius, PSI, whatever works for your operation. And then the data storage and alerting all happens based on that value in FreeWave Edge. So you don't have to do that conversion far away in the field where it's hard to know whether you've got it converted right. We can also update our polling interval here. So we are set up to poll every 30 seconds. And then to know that you're configured properly, we also show these last readings. So when you're out in the field trying to know what's going on, you can check out this last readings column and say, yep, I know I've got the right value coming in here because this matches what I see in the field. So for example purposes here, we are doing some internal radio diagnostics polling. So this is between the computer, the Edge Compute Platform board and the Z9 radio board. So we are looking at the signal level, signal margin, signal noise diagnostics on this particular demo. But if this is any external Modbus device, it's all treated the same way. So now we've got our data inputs going in. Now we need to configure our data publishing and our data processing. So MQTT is the main method. We send data histories and we send data via real time. So here you would set up your MQTT broker, whether that is an on-prem Raspberry Pi or server, or whether it's a cloud system like AWS or Azure or ThingsBoard or some of the other cloud systems, we have instructions for how to send all of those. And here we can set up for the store and forward feature that I talked about, we can set up our interval. So it defaults to once an hour, but you can go as fast as every minute. So in our every minute example, if we're polling data once per second, every minute we are sending a history of 60 samples, 60 seconds worth of data is being sent efficiently over the air every minute in this example. We also have 3 different data formats here. So depending on what works the best for your IoT or your SCADA system, we've got a couple different options here for store and forward. We also have what we call real-time publishing. So real-time publishing is instead of waiting for store and forward, we send the values as soon as they come in. So we can enable real-time publishing, we can publish only changes, and we can say as soon as this value changes, we want to publish it. And this happens via MQTT SparkPlug-B. So here you see a couple SparkPlug-B specific things about group and node that you name for your operation, whether it's FreeWave Boulder or FreeWave Colorado, whatever works for you. And so now, with just those 2 tabs, you've got a working system. The other thing I wanted to show you guys today is the concept of alerts. And we've got customers using that right now. So wanted to show you how that works. So I'm going to select our signal noise sensor, and I want to know, I can choose either a threshold or a rapid change alert. And I want to know when this signal noise is greater than or less than a threshold. But if this was temperature, if this was pressure, your custom units show up here. So this would be PSI, degrees Fahrenheit, whatever. And we're going to put in an alert we want to learn about. And we're going to say for more than 10 seconds. And now I get to choose where that alert goes. So this is, we have an option for MQTT, or we have an option for email. So you can send an email via your Office 365 or Gmail account, and it'll go out to wherever you need it to go. The other nice thing about this is all the cell phone carriers have a special phone number at a special carrier specific domain name, so you can actually send text messages via this system as well. So you can use store and forward to get all your data, use the alerts to immediately know when something is going wrong. So we're going to put in an alert here. We're going to hit next, and we're going to call this our Wincom demo and hit finish. And now we've got our alerts showing up on the screen here, and we are able to get emails, get MQTT messages as soon as those are coming in. We also have the alert summaries as the last screen here, so you can get a daily report email once a day, the full history of all the alerts that have happened that day. So now you've got a working data path from your edge devices and your PLCs back over the radio to your cloud system or your SCADA system. So now we're gonna switch gears back to the presentation. So hopefully with that, you see the ease of use we're going for and the simple, straightforward data configuration to make it easy to get your data at a higher resolution and more efficiently than you were able to get it before. The other thing I wanted to cover is some of our early customer usage on this. We have a city electric and water utility case study. So they are using the Modbus capability. They are retrieving data from new PLCs as part of a system-wide upgrade. But one of the things that was important to them was the ability to support legacy protocols simultaneously over the air. So they're doing a transition from an old system to a new system, and we can support the SCADA system working with those legacy protocols over the air while we're also upgrading to FreeWave Edge and new PLCs. The other case study we have is an oil and gas production operation with several hundred wells. So they are using FreeWave Edge and Modbus to get data out of a ABB total flow. And for them, this is replacing a expensive satellite-based monthly fee alerting system that was, costing them a pretty high amount each month. And they are using the alerting to send emails via their Office 365 accounts, and they are also using that to send text messages to the pumpers and different people in their operation so that they're more in touch with the day-to-day performance of their equipment. So that's, we wanted to give you a flavor of how this is really being used in the real world. And then to wrap up with a couple points. So pricing and availability, this is $150 list price. We have the part number here on the screen, and we would love to hear from you to do some installations and see if this product can be a good fit for you. This is available on the Zoom link. So the Edge computer with the 900 megahertz radio, the Zoom IQ, which is the Edge computer with no radio, and the Zoom Edge, which is the Edge computer with the IO and the radio. This will also be available on our new Fusion Bridge, which is also coming out. The other little teaser here is a beta feature. If you're an existing FreeWave serial radio customer with an FGR2 or FGR3 network, we do have an option to take the over-the-air polling with your serial radios, and we add a Zoom IQ at each end. And so this gives you the Ethernet capability and all of the capability you saw today with FreeWave Edge, but you can keep your existing radio infrastructure in place, keep polling to all your sites, but install FreeWave Edge or install a Zoom IQ on some of your most important sites that you want to get more data from. So that is currently in beta, and please contact us if you're interested. So everything you saw today, everything in the demo is available for that $150 list price, but we are continuing to add to this platform, and your feedback is going to be very important to us to add to this platform. So today we've got available the Modbus, the IO, the ROC, we've got the store and forward, we've got the alerting, but we are continuing to add to this. So we're adding Bluetooth sensors, we've got additional protocols on our list. We've also got this idea of PLC Lite to be able to do very simple controls without having to learn Node-RED or pay a programmer to code something for you in Python. So you could take the data inputs from FreeWave Edge and control that with data outputs. So we are continuing to add to this, and if you're seeing this presentation and thinking, oh, that's nice, but I really wish FreeWave could do X, well, please be in touch with us, and we'll have a discussion because we definitely want to make sure this is working for you in the real world. And with that, I am going to say thank you. Thank you.